All right.
Hey, let's keep
So,
talking and make her
so
kick us out.
today, we're going to verify trigonometric identities, which some kids like this better than yesterday because it's very obvious when you're done. These are the proof ones where you've got to get the left side to equal the right side. And I do have to be incredibly picky about you guys showing the steps. So none of this, well, I did it because it's obvious and it's in my brain. No, it has to be on the paper. And I'll show you exactly what I mean once we get going on the questions. But I will warn you on your homework, guys, I didn't post the answer key because these are self-checking. Like, you don't need an answer key. What I did post are parallel questions. So, like, I might have assigned you number 7, but I did number 8 because it looks a lot like it. So I worked out some parallel questions like a student solutions manual, and that's what I posted for your answer key for today. So number 1, don't do extra problems, and number 2, don't go looking for all the worked out identity trades because I didn't do it for you. Okay?
The internet did.
Oh, child.
Hey, look.
Don't even.
We'll make a science club.
A science club.
Science club.
Oh, that'd be fun.
We argue too much.
Me, you, and Jacob are the founding members.
Oh my gosh.
And
They're
Mrs.
talking
Abruzzo will be our sponsor.
internet. They're talking about black holes again. All right, guys, come on. Your sponsor. Do I have to do anything?
We just need your class. Yeah, we need a faculty member.
I can bring food and candy and watch it. I will sponsor you. Go ahead, petition it. But, child, you're about to graduate. Is this your legacy? This is your legacy?
I'll carry it on, Daniel.
I'll have to Google your theories and see if they even make sense.
We'll just make up our own theories.
No, we have to have logic behind them. You can have
Lordy.
illogical theories with logic.
You want to talk about logic? This is as logical as you can get, guys. Ready? Trig identities. Man. All right, here we go. So this one's already done for you. So what I want to do is kind of point out how the work looks and what they're doing and just kind of the theory behind why they're doing these trades. So remember on trig trading, you can technically trade either side up. The point is all your work has to happen on one side. Now, some teachers are very picky about, like, you have to keep writing equals sine squared x, equals sine squared x, equals sine squared x, all the way down the line. I am not that picky. So what I like to do is just have all my work going, usually down the page, but if I have to go horizontally and make it snake through the page, that's fine too. And at the end, I go, check, and that's how I know I'm done. Yes, Daniel?
Do you expect me to probably be forced to write equals sine squared x in a college?
Oh, yeah, all of my professors made me do that. Yeah. And actually, the proofs end up, this is like low-level proof. Well, these are like low-level proofs. They're very, like, easy in comparison to what you're going to have in college. In college, they're much more fun. So, the geometry ones are lame.
Yeah, I don't like those at all.
No. The ones you'll see in college are, they have different techniques of proving things true, and they're very algebraic in nature, so they're kind of like this.
How to make 1 equal 0.
Yeah. Like that. I know. You like things like that. I think you'll enjoy proofs in college. But, you know, save that for your science club. That could be a whole day.
No, that would be math.
Oh,
I
dang.
don't have enough time to do
What if-
club.
You'd be president, co-president. All right, here we go. They did some trading.
Science show.
Let's see if you can figure out where this came from. They looked at secant squared x minus 1, and they recognized that to be one of your Pythagorean trades, right? That's a Pythagorean trade for tangent squared. Do you guys see on your blue sheet where we're finding that? Yes, have the blue sheet out. So I believe it's the middle Pythagorean. Yep, it says tangent squared plus 1 equals secant squared.
Yes.
They manipulated that one. All right. So then they went back and they said tangent and secant, I can't deal with that. So then they traded them for their sines and cosine ratios. So tangent, known as sine over cosine, which means the sine squared over cosine squared is another way of saying tangent squared. And then instead of saying secant squared, they wrote it as 1 over cosine squared. And then they went back to 5th grade and they said, how do you divide fractions? Because you don't divide fractions. Yeah, you change it to a multiplication problem, and then you take the reciprocal of the secondary fraction, the one that follows the division sign. And then they saw some cancellation, which is obvious, right? The cosine squareds cancel, which leaves you with sine squared, which is what we totally wanted at the beginning of the problem. So then I put a check mark, and that's how my teacher knows I'm done. Mrs. Hofbauer puts, like, equals right-hand side, check. I don't really care if you do that. Okay? So, here's the annoying part about identities, is that you have to show all of this magical stuff that's going to happen in your brain. So you got to kind of slow it down a bit. You also can technically work from either side, but you want to work with the side that has the most promise. The messiest side you can find. The one that needs the most work. So I'm feeling the left side needs the most work on number 1. So, I noticed there's nothing squared, so don't go Pythagorean yet. You have no trades available to you other than the reciprocal trades. For instance, give me another way to say secant.
1 over cosine.
Very good. And these are not given to you on your formula sheet, so you do have to memorize this. We have subtraction. Cosine, I don't need to trade. It's just cosine. But because I can see we're dealing with fractions, I'm going to write it as cosine over 1. So now I got to go back to 5th grade and think about how do I subtract fractions. I get common denominators. So for my notes, I'm going to write myself a little note that I'm getting common denominators. Now, what will be the common denominator down here for your next line?
Cosine.
Yes, cosine theta is the common denominator. So this fraction has the denominator, but this fraction is missing. This is the step you're not going to like because you're going to be lazy, and you can't be lazy. How do you get common denominators? Like literally, what are you doing? You're multiplying by the missing component. And you're multiplying it to both the numerator and the denominator of that fraction. You have to show me that. I know. I'm just as guilty as you guys. I get real lazy, and I'm like, I write like a giant cosine diagonally, like trying to claim that that is a thing. That's not a thing. Okay, so you have to show me that, and I know it's annoying. Now, the work, you don't have to show me. It's the setup that you're showing me. Yes, Daniel.
So, like, I couldn't just write cosine squared over cosine theta.
I want to see this. Yeah, I know. And that's where, yes, it gets irritating. And you want me to be able to trust you that you know how to do that. But here's the other thing. You guys are very bright. So if you know where you're supposed to end up, a lot of kids can work backwards without actually knowing what the heck they're doing, which is frustrating as your teacher. Because I want you to do it right. Just trying to get you ready for your astrophysicist life.
How you got the answer.
The answer is the answer. How I got it is irrelevant.
I'm going to be at home pilot.
Dang.
All right. So now this next step, I would like you to, like you went through 5th grade, you guys know how this works. You write it as a common denominator and your numerator becomes its own little thing. So your numerator is 1 minus cosine squared. Which now, I do have a Pythagorean trade. This guy right here. That's a Pythagorean trade. So I'm just writing this down for my notes. I don't necessarily have to do this when I take my test. It's a D. What is 1 minus cosine squared if you rearrange that baby? It's sine squared. All right, you're not going to like this next part either. Because there's kids out there who are like, I don't know why, but I'm done. And then they just write down sine tangent. Because they know that's what they're supposed to write down. There's one more step you have to show me. You have to show me you understand what sine squared means. Sine squared is sine times sine. So you're going to just take sine squared and you're going to split it.
And that's going to be over 1.
I know. I know, Daniel, this is why you don't like these. I get it.
Wow.
But you got to show me.
That's fascinating.
So then this is where Daniel's like, and we're done, because look at this. Who's that?
That's it.
That's tangent. And clearly that's sine. Which is what we wanted, right? I kind of forgot what the problem was. Tangent, sine, sine, tangent. Same thing to me. Check! So the frustrating part is actually going through and showing that. I gotcha. It is frustrating. It's the same reason why proofs were frustrating in 10th and 9th grade, because you were like, because it is! You didn't want to have to explain yourself, okay?
Why can't we just trust that it is?
So when I am writing a verification for an identity, as a child, what I used to envision was if I was showing work to my dumb best friend. You know who you are. If I was going to try to show my dumb best friend how to do the problem, like show them explicitly, I did X, Y, and Z steps. And that's how I kind of approached them. And my teachers were always happy with my work. So think of it that way. Think about your dumbest friend. And what would they need for you to... I am the dumb friend. Okay. Don't say that. That's disparaging. All right, number 2. Clearly there's not much going on the left side. Leave that one alone. Let's work with the right-hand side. So, there's some, I'm hoping some algebraic thoughts going on here, guys. Do you have any thoughts about what's happening over here? Like what you could do? I feel like we should totally distribute that. Now, I am not opposed to you guys distributing and also trading at the same time, because you're going to very clearly show me what you did here. So, sine, nothing to do with sine, just sine, times, can you go ahead and trade out tangent for me? Yes, Daniel.
Why can't we just divide both sides by sine?
This is not an equation that you're solving. You're manipulating the right side to look like the left side.
So we're not ever going to move anything over.
Nope, no moving across. Yep. Big old boundary line. You're not solving it.
Why do we have to learn this? What will this benefit us in our future?
You know, it's funny. I've been asked this question a few times today. Okay, so the act of what we're doing, this is called manipulation. This is key to upper level mathematics. So like you'd go and you take a differential equations class in college, which is going to be necessary for most of you who are going into these fields you keep telling me about. And calculus is under this umbrella too. And you get this equation that is like a messy ball of yarn. Like, I don't even know where to start. So you have all these like tools in your tool belt of what you can do to an equation on the most basic level of your pre-calc life all the way up through eventually diffie-q. And you're like, okay, well, you know, my action of getting common denominators when there's a gross fraction, I can trade these out, I can factor, I can distribute, I can create conjugates. These are all things that we practice for years and years and years, because when you get to this messy ball of yarn, and guess what, guys, real life equations, not pretty. You have to be able to manipulate them so that you can actually solve them and do something with them. Because the way they look when you are exposed to them, unattainable. What do you think the scientists working with the black holes do, Taylor? You think they get these beautiful equations that are ready to factor? No.
I think I decided that I want to be a puzzle.
Hey, I was watching this video.
But thank you for the question.
They were trying to figure out how far away the black hole is, and they used a trig equation. I was like, oh,
Yeah.
I do understand this.
Yeah.
I understand
No,
that.
there's like tons of this applied beyond. It's just, it's hard for you guys to kind of get the big picture because, okay, so there's several kinds of students out there in the world, and some students ask that question legitimately because like they do have a vision of where they want to go, and some kids ask that question because they're just trying to be buttheads. So I appreciate that you guys are asking it like legitimately. You want to know. You just
I'm asking them legitimately.
oh, never
I was
mind.
asking legitimately.
So
Daniel.
Daniel. I'm gonna keep this video. And future Daniel, I'm gonna be like, come here, child. He'll be a child then. He'll be a helicopter pilot. No, I think you'll do your engineering thing. You'll come back and you'll be like, Mrs. Bruce, you were so right. I'm so happy you made me manipulate all of those trig equations. Because that made college so much easier. I was the kid who just did everything my teacher said. Like, didn't ever cross my mind to think, why would I need to know this? Because I enjoyed math. That was part of it. But I just did whatever I was told. And what I found is when I got to college, I was one of few people who had the tools in the tool belt to handle the high equations. Because we did so many of them, right? That was like all we did once we got to PreCalc and beyond. Yeah. Yeah. That's crazy business. What do you do?
He started at Woodward, and then he had a lot of experience, and was offered a job at Sunstrand.
That's very cool.
And then he
Sometimes that,
10 years is equal to a master's degree.
yeah, and a lot of times your work experience or an internship that you end up taking, and Woodward has a lot of great programs too.
he was the best in his program.
That's awesome. And I'm here, just doing this forever.
Well, you have 10 years of experience. You can go.
Do this more.
He'll be a professor.
Wait, yeah. Why don't they consider you to be a professor with a master's degree?
My master's is not in math. It's in education. Science and education.
Science?
It's a... Alright, so we should be checking this out, guys. Look at this from an algebraic standpoint. Something here has to look prettier. Can you give me a little cleaned up version of this? What does that say? It's sine squared. Yeah, sine squared over cosine. And then over here, oh, something kind of cool happens. Do you see it? The signs are going to cancel, which I know sometimes we don't want them to cancel, but in this case, I think let's let it happen. So I am going to call it cosine over 1. And now I'm inspired by my 11-year-old self to get common denominators. Are you?
Yes.
Cool, let's get them. What's going to be your common denominator?
Cosine. Very
good. Good news. The first fraction has the common denominator of cosine. However, the second fraction is missing it. So this is the annoying part. You guys have to show me cosine over cosine. Other than that, you don't have to show me any more work. All right, so what's going on here? We got a sine squared. Now we have plus cosine squared. And that's somebody pretty. Who's sine squared plus cosine squared?
1.
Yeah, this is a Pythagorean trade. That's a 1. And then I know you're like, we're done. I know, but you still got to show this next step. Right? 1 over cosine, better known as secant, which is totally what we want to check. I think you will, because if you've noticed so far, almost every question I've asked you to do, there's involved some 11-year-old fraction work, right? Like common denominator.
It doesn't feel like math. This is words. Oh. Yeah, it does.
I was.
You weren't even paying attention
I had
to me.
an out-of-body experience for that entire time.
Daniel's parents, I'd like you to know, he did not pay attention to any of the notes today. I'm going to save this for conferences on Thursday. Got it. All right. You're going to like number 3, guys. Now, first of all, do you notice 3 is a multiplication question? I get kids who are trying to get common denominators on this, and I was like, child, what are you doing? All right. Clearly, the left side is something we can work with. What you got here, guys? What's tangent? Sine over cosine. Let's trade up cosecant. That's 1 over sine. Oops, you said sine. I wrote cosine.
Over 1.
That would be a good idea to write it as cosine over 1, because
This. I love it.
oh, this is going to be, oops, that's not at all what I wanted to write.
That's a lot of, holy snaky. And all kids.
Boom, 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 boom. Look at that one. Check.
That was so nice.
They're multiplication questions, so it's like one big vinculum.
Oh, nice.
I feel like that's not allowed.
It's not allowed. It's too much scribbling.
It looks like it shouldn't be.
No, it's very much allowed. The
There's-
shorter it is, the more it's allowed.
There's a question like that on your test where it's just like trade, 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 boom, 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 done.
And you just have to know,
That's the
like,
kind of
tangent.
Yeah, you do have to know. The tangent, cotangent one might get some of you. The reciprocal is always a
I feel
problem.
like I messed up so many times that I'm tired now. So know it.
Oh, see, I go paranoid when I get that right. I'm like, I've messed up so many times now I don't even know when I'm right.
No, I think I know.
Okay, good.
Why would they not make secant the inverse of sine?
I know. This has always been my complaint. When you were just, right? Well, the co-functions have a different relationship. Cosine and sine are co-functions. And remember that co-function theorem yesterday? You totally remember because I taught it to you. That they have a relationship. So that one I get. But I'm with you. The reciprocals, that was just named willy-nilly. I don't think there's any reason why they're named secant and...
Right, so can we
Well,
start
okay, you know what? I
petition?
take that back. Secant and cosecant are co-functions to each other. I guess that's why.
So
I'm
my
irritated by it,
petition
yeah.
to change.com, okay,
Just to
is
change the
to
inverse
switch
function
those
name?
Inverse functions.
Okay, but they're not inverse functions. They're reciprocal functions. I trapped you.
Different.
Totally different, Daniel. We just had this conversation yesterday.
No,
Okay,
but I still think they're named.
I think the left side has more promise. Let's manipulate some stuff on the left-hand side. And now, I get a lot of kids who are like, Pythagorean trades are my favorite. That's great. I don't see any. How do I know I don't see any Pythagorean trades right now?
If there are.
Because there's nothing squared. So don't start trading things when they're not squared. But we can trade him for his reciprocal buddy. Or whatever Daniel wants to name him.
Huh?
That's the one you're going to rename, right? Cosecant? All right, cotangent. Give me a better name for that. Very good. Oh man, this one's going to take a lot of work. Hope you're writing small. And then tangent is sine over cosine. So then I get some really adorable things from kids. They're like, these sines and cosines cancel. And I'm like, that's not a thing. All right, so this is an addition question. You need to go back to 5th grade. How do you add fractions again? Common denominators. So this is going to be a little annoying. I'm not going to touch the 1 over sine right now.
So we have cosine squared.
But talk to me about what your common denominator is going to be for this. This is called a complex fraction, a fraction within a fraction, and it has an addition problem in it.
Sine cosine.
It's going to be sine cosine, yeah. Okay. So this is the part you're not going to like. You got to show me that you're getting the common denominators. Yes, Daniel, I know. So you're multiplying this guy by sine over sine. And oops, I wrote too big. You're multiplying this guy by cosine over cosine. So I already wrote down the denominator, but could you tell me what's going on in this little secondary numerator here? Good. Cosine squared plus sine squared. Ooh, somebody. We're not done. Crazy kid. All right. This is still 1 over sine. I have yet to do anything with that. But what's cosine squared plus sine squared? That's a 1. All right. So here's what I'm going to do. I'm going to write it instead of a division question. I'm going to think about 5th grade again. I'm going to flip this around and change it to a multiplication question. So this 1 is now down here. And I still have sine cosine, but now it's up top. Oh, we got this. Sines will cross cancel. This is a multiplication question, so you're allowed to do that. And y'all got cosine. Is that what we're supposed to get?
Yes. No, cosine.
I'll go back to the beginning.
How? It's
Do you not even have the page open? You don't even open to the lesson.
how are you gonna?
Daniel, how would you know where we were going? You didn't even have the problem in front of you. Oh, gosh. All right. 5. 5's a hoot. All right. At first, I was like, oh, 5th grade fraction, subtraction problem, cool beans. At first, I was excited because I thought they had common denominators, and then I looked a little more closely and realized they do not have common denominators. So we're going to manipulate the side I am going to get common denominators, but what's going to be in my final common denominator for this question? It's all of it. It's sine y minus 1 and sine y plus 1. This is very a la Algebra 2, where your teacher gave you a rational adding problem and you had to get like both binomials in the common denominator. It was gross. We will. Okay. So this fraction is missing the sine plus 1. So I'm going to do that very annoying thing where I write it, both the numerator and the denominator. And same thing over here. This guy is missing the sine minus 1. So the good news is the denominator's all set up. The bad news is this numerator is a hot, hot mess. Now the good news is 1. That doesn't do anything, right? 1 times sine y plus 1 is just sine y plus 1. But be careful right here. This is a subtracting 1 that you're distributing into the sine y minus 1. So if you were to distribute a negative 1 right there, you'd get a minus sine y plus 1. Very good. I was worried about that. So the signs do cancel. We're simplifying right now. 1 plus 1, better known as 2. And now I think about where I'm trying to go, and Daniel's suggestion earlier about what if we like FOIL and distribute this out, I think that would be a wise choice right now. So sine times sine is sine squared. These are conjugates of each other, which means the arches of your distribution will cancel out, so I'm not even going to write them down. And then negative 1 times positive 1 is negative 1. Ooh, that's somebody, but wait, we got to talk for a moment. My favorite Pythagorean is sine squared plus cosine squared equals 1. Could you manipulate it so it says sine squared minus 1? So you would have to subtract the 1 over. But what else would you have to do? Subtract the cosine. Yeah, this is just the identity. This is like a little aside, okay? You'd have to subtract cosine squared to the other side. Oops, you can't read that. All right, so here's what we got. Over here, we've got sine squared minus 1. Here's the 1's canceled, and you got a minus cosine squared. That was a very unusual manipulation of that identity. Sine squared minus 1 is equal to negative cosine squared. So we are trading right now. This guy trades for negative cosine squared. And remember how you had that 2 up top? Guys, I think we're there. If forget the 2, forget the negative. If this was just like 1 over cosine, that's secant, right? So I'm going to throw the negative up with the 2. 1 over cosine squared is secant squared. We'd be done. Yeah. Back it up. Okay, so if I took this fraction right here, and I kind of pulled the pieces away, right? So I'm going to throw the negative up with the 2. Let's just get that out of the way. And then it's like times 1 over cosine squared. Forget the squared for a minute. What's cosine? Or, sorry, what's 1 over cosine? So this is secant squared? So there we go. Yeah, that was a difficult one. And that's one where I'm going to be honest, if this was on a test, everybody in here would have got to that last step and been like, yes, I'm sure it equals negative 2 secant squared. Magic. Because you're not really showing me anything there. Like, we're just kind of all agreeing that they're equivalent. But now we totally get it, right? We get that they're equivalent. We're okay with this? You guys look like you're not okay with this. Well, you're not going to be okay with this one either. I hate to break it to you. Before we look, and we're going to manipulate the left side, believe it or not. I'll show you why in a minute. Who remembers this? The difference of cubes? Remember this guy? From August? You don't remember everything we've ever done? That's the difference of cubes factoring pattern. You have that. This guy right here. That is the difference of cubic factoring pattern. So the way the pattern worked out is like when it was variables and numbers, you had to cube root the terms to figure out who A and B were. Well, this one's not too bad. What's the cube root of sine to the third? Just sine. And what's the cube root of cosine to the third? So there's your A and B. All right, ready for this? The pattern goes A minus B, so sine x minus cosine x. And then it's A squared, so sine squared x, plus A times B, sine cosine. And then B squared, cosine squared. All right, I'm about to do some math magic. Ready for this? I think about where I'm trying to go. This is what I want this side to look like. But looky here. I have that. So I'm not going to touch that binomial. I'm going to leave it. Let's focus on this guy and what we can do or trade or identify that will make it look like this. Ladies and gentlemen, look at the beginning and at the ending of that. What's sine squared plus cosine squared? Oh, that's all 1. We're done. So I'm not even going to bother to rewrite it in the proper order as the identity on the other side because I really don't care. But what I do want you to recognize is that sine squared plus cosine squared, even though they're kind of separated from each other, that does identify as a 1, and then plus sine cosine. I don't know why I made that parenthesis so large. There we go. Check. Well, that was a good time. So what I just learned from that question is you can pull out old school factoring patterns in Trig. Oh, great. They aren't usually the cubic pattern. Usually when I ask you guys to factor, they're pretty boring factoring questions. All right, number 7. Well, the left side has some work to do, right? Let's work with the left side. We can trade out tangent for sine over cosine. Guys, this is the stuff in math, by the way, where if you don't do your practice and homework on this, you will bomb this test. That is not a challenge I'm posing for anybody. All right, we are not challenging you to try to do that. I'm just telling you from experience, you will be bombing the test. Okay, there's no trading I can do right here. But we're going to need to live our best 5th grade life and get common denominators, yes. So our common denominator would need a factor of cosine and 1 plus sine. So this guy over here is missing the 1 plus sine. And this guy is missing the cosine. So your numerator, this mess, you can go ahead and do, take the liberty of simplifying it. We got 1 plus sine times sine, so that would end up being sine plus sine squared. And then plus cosine squared. Now the last two things I just rattled off, that seems wonderful. What's sine squared plus cosine squared? It's a 1. It's my favorite trade. All right, guys, we're almost home free. You've got a sine plus 1 over a cosine times a 1 plus sine.
Oh my gosh.
Do you see it? Now, we don't usually put that in parentheses, but it technically is a group. And these groups match. You got some cancellation. So you end up with 1 over cosine. Please tell me I'm trying to get to secant. Oh, good. Check. So that one had a lot to it. It had a common denominator right off the bat. It had a Pythagorean partial trade. Like part of the numerator was a Pythagorean trade. And then you had some canceling of factors, which is, these are all like tools in the tool belt that we're going to have to use. Some problems are more fun than others, right? Some of the problems, like, you got a lot of things you got to think about. Oh, you know what? We better do this one. So I think this is very similar to the last question. There's no trading right now. It's all sines and cosines, but I definitely need to live a 5th grade moment and have a common denominator, which would be a sine and a 1 plus cosine. So this fraction's missing the sine. And then this fraction's missing the 1 plus cosine. Oops. So I already wrote up the denominator. Let's talk about what's going on in this numerator, though. Ooh, yucky. All right, sine times sine is sine squared. Thank goodness there's a plus sign on the next part, because I've seen a question where this was a subtraction sign, and that creates a whole nother level of issue in your problem. So, yay for plus signs. You're going to have to multiply these together, though, guys. 1 plus cosine times another 1 plus cosine. That, children, is a foiling or a distribution question. So 1 times 1 is 1. And then you're going to have 1 cosine plus another 1 cosine. So you got 2 cosines. And then cosine times cosine will give you a cosine squared. Now, I got my eye on the answer, but like we're not there yet. But think about the last question. I think there's a Pythagorean hiding in here. There he be. So commutative property, you could rearrange this if you wanted to, but if you see that trade right there, guys, that's a 1. So right now, I have a 1, and then there already was a plus 1 plus 2 cosine theta. And this is where kids get in trouble, because they're like, I'm sure these are just equivalent, and then they stop here and they just write 2 cosecant magically. We still have some steps to do. For instance, the numerator, 1 plus 1, better known as 2 plus 2 cosine theta. And again, kids are like, oh, I'm sure it works out, and they just stop here and they write the answer. Nah, not yet. There's one more thing you got to show me. Look at that numerator. This is that warning your Algebra 2 teacher and Honors Algebra 2 teacher kept giving you. At the end of adding and subtracting fraction problems in algebra, there once in a while was a question where you had some last-minute factoring and stuff canceled. And I think we have that. Do you see anything you can factor in the numerator? You take a 2 out of that. This is 2 times 1 plus cosine. And when you combine that with the fact that your denominator was a sine times 1 plus cosine, you see that canceling now? Kaboom! There we go. All right, so I'm out of room. This has 2 over sine, which is 2 cosecant. Ta-da! Check. That was a hoot. All right, so the rest of the notes, here's what they're showing you. Sometimes your problem doesn't say, like, verify the identity. It says something like, check to see if these are even our identities. And rather than, like, suffering through the algebra, you can test this on your calculator if you're in radian mode. Now, in particular, I want y'all to look at number 10, because the issue we're going to run into for kids is they don't type number 10 in properly. In Y1, if you were trying to type 2 minus cosine squared x, this function, because the cosine function is squared, you have to have a set of parentheses around the cosine function before you hit the squared key, but your calculator will also open up a cosine parenthesis within it. So you need like double parentheses on that question, and when kids type that one, they don't type it right, and that's the issue they run into.
So it's 2 minus parentheses.
Cosine, parentheses, x, yeah, and then close, and then square.
It's only 2 times.
Yeah, I know the red ones are getting in the way, aren't they? So like here it'd be parentheses, sine, open, close, x, close the final one before you square it. Now what happens then is when you guys graph this on your calculator, I don't think I have a picture of it, but you'll, especially on the color screens, it's really easy to tell. Your blue one will look like one function and your red one will look like a totally different function. And that right there proves to you that those are not identities, because if they were identities, they'd look exactly the same and they'd be mapping on top of each other. So if you're ever asked in the future, like, are these even identities? Rather than doing all the math, you can just graph it. Hey, what mode should your calculator be in when you're graphing these? Radian mode. And then you'd set up your window however you want to set it up, but negative 2 pi to 2 pi is what your book suggests. All right, so your homework, what you need to do, guys, please. And remember, the answer key is not these questions. The answer key is other questions, in case you get stuck and you need some inspiration. But if you think about like all the tools we used today, big one today was common denominators. There's a little factoring. There's a lot of Pythagorean trades. There's some foiling and distribution in there. So all sorts of algebraic things that we got to practice. There's no way to learn this without practicing. I promise you it will not go well if you don't practice. All right, how inspiring. Good luck.